How's it going, everybody? I'm Cody. I'm here on staff at Learning Fuse. For those of you who are part of the program or people who are just coming to join us for the talk, we're an accelerated web development program, and we like to try and participate in the community as much as possible. We're honored to have JavaScriptLA here and James to tell us a little bit more about TypeScript. And if you want to hear more about the program, I'm always available to talk to, but without further ado, let's let James take it away. Thank you for being here, man.
Thank you.
Yeah. All right, thank you. So as we just mentioned, I'm James Earle, and I'm a technical evangelist at Microsoft. We talked a bit about what that means. That's my Twitter. It's James IRL. If you want to hit me up on Twitter, I'm pretty active. I like to communicate with people, lots to talk about all the time. It doesn't have to be about TypeScript or any development, just if you want to chat. I'm always open to it. And before we dive in, I just kind of want to poll the crowd a little bit and just ask, who here has used TypeScript before? One. Okay, who here has never even heard of TypeScript before? A couple more. Okay, perfect. Yep, great. So, one thing I really want to point out about TypeScript is that it's a really kind of beloved technology. It's up and coming. Here is the Stack Overflow 2017 developer survey. And you can see that TypeScript came in as the #3 most loved developer language. So I think that's pretty cool. It kind of speaks volumes about what people are interested in doing and what tools they're interested in using. You don't see many jobs requesting TypeScript developers. A lot of the time, the jobs are kind of behind the trend. But I think that's going to catch up. I think TypeScript is definitely something you should keep your eyes on. And it's worth learning, especially if you're into JavaScript. So, what is TypeScript? TypeScript is a typed superset of JavaScript. So this means that all valid JavaScript is valid TypeScript, but not the inverse. So TypeScript adds extra syntax and semantics to give you optional static typing while you're developing. And then it compiles it down into plain JavaScript. So a kind of visual representation of this is right here. So everything that's JavaScript is TypeScript. And that means that anywhere you can use JavaScript, like Electron, Node, just regular, maybe jQuery in your browser, you can use TypeScript as well. And in my personal opinion, anything JavaScript can do, TypeScript can do a little bit better. So why would you want to use TypeScript? The main reason, as I said, is it adds optional static typing. And this static typing, I really want to emphasize optional here because you can use a compiler file called the tsconfig.json to specify how strict you want the compiler to be. So if you want really rigid code, you can make it that way. Or if you want it to be a little bit looser because you're more familiar with vanilla JavaScript principles, that's fine too. So there are also object-oriented principles involved in TypeScript, and I come from a Java and C# background. So this comes really naturally to me, and I think it's pretty great. A lot of people don't necessarily agree, and that's fine. You don't have to use it this way. You can still use it procedurally, just like regular JavaScript. Also, developer features like really great IntelliSense and compiler warnings make the development process extremely easy. It's very pleasant to develop in TypeScript. One thing I do want to note, though, is even when you have compiler warnings in your TypeScript code, you can still compile down into your vanilla JavaScript. So that's just because no matter what, it should be able to provide a file that it can run. But if the compiler is telling you that there are problems, you should probably be listening. Don't trust yourself. The compiler is smarter than you, for sure. And in most cases, you might want to say, well, I know that I'm really trying to do this, but if your compiler is yelling at you, you might want to abstract or refactor your code in some way. So how does it work? The general principle is that you write in TypeScript, you use the TSC compiler tool to compile it down to vanilla JavaScript, and then you run it in whatever environment you're using. So you could be using Electron or Node, like I mentioned, and that means that if you're using an app.ts file for TypeScript, once it's compiled, it becomes an app.js file, and you can run that and set that as your entrance point into your Node web app. So here's an example. These are a few of the commands you might want to use to get started. First, you have to install TypeScript, obviously, so that's just an npm install. And then you'll create a project directory and enter it, and do this command, tsc --init. And this creates your tsconfig.json. So this is where all of your compiler rules are going to be stored, and every time you compile your TypeScript, it's going to check this file, check which rules you have turned on and off, and adjust accordingly. It's actually also dynamic, so while you're typing, it's checking this file, and if you violate any of these rules, you'll get a red squiggly underline to let you know that, hey, this is not going to behave well with our compiler. Here's an example of what some TypeScript code looks like. You can see that it's almost the exact same as regular JavaScript in this example, except for one thing. Right next to the parameter val in our function, we have a type annotation, and this type annotation is saying this can be anything. This can be any type. And this is good. This kind of works a bit like vanilla JavaScript variables. They just can be anything. And normally, when we have anything, we need to do a little bit of type checking. Right now, all we're doing is console.log the given parameter, so we can really pass anything into it. So this is just to show you what it compiles down into. You can see here that once we've run tsc on our file.ts, app.ts, whatever it may be, the type annotation is removed. And that's because it's not like vanilla JavaScript does not support that syntax, right? So if we had :any here in a vanilla JavaScript file, that would just hit an error, and that function wouldn't run. So the type annotations and all of the TypeScript features are to benefit you, the developer, and they really enhance the development experience. Also, this is good to note because all of the extra code you might be writing isn't going to affect your actual code base. So your deployment to your web server is going to be the size of your JavaScript, not your TypeScript. So let's talk about the default types involved in the language. These are the main ones: Boolean, number, string, any, array, and tuple. Boolean, number, and string behave exactly how you would expect them to. A number doesn't have to be any specific type, I guess. It can be decimal, binary, octal, or hex, and you don't have to clarify which one it is necessarily. The any type, like I mentioned before, behaves exactly like variables in regular JavaScript. Array is also the same as regular JavaScript, and tuple is a bit of an interesting case because it's just like arrays, except they are strictly ordered sets. So if you define a tuple as being an array that has one number and then one string, when you create an instance of that tuple, it has to follow that structure. If you reverse the types, or if you have different types in your array, that's going to be an error. And again, that error can be ignored. You could still compile the code and it would work fine. But then you're going to hit issues that you might not foresee. So again, always just listen to the compiler. We also have an enum type, which if you've used Java or C# or anything, that's not too unfamiliar. This is basically just a mapping of values to developer-friendly properties. So if you've got a bunch of hex codes for different colors, you could use color.red, and it would map to something, whatever you want it to, like hashtag FF0000. Then there's also void, null, and undefined, which again behave exactly like void, null, and undefined do in vanilla JavaScript. So here's just a look at what some of these might look like. So we have a Boolean, number, and a string. Again, the number can be a decimal, an integer. That doesn't matter. It supports hex, binary, and octal as well as decimal. Array is the same. And here is how you would define a tuple. So remember what I said before. We're defining this as being a number in the first space in our array and a string in the second space in our array. So if we try to add a third element, that's not going to work. If we try to add anything that's not a number and then a string, it's not going to work. So Then there's also enum, and the reason I actually separated enum from the rest is because all of these you instantiate, but enum you can it's kind of like an interface. You just define it, and then you can use it later. So you can say color.red in your code somewhere else, but you don't say let variable name equal enum color.red or something like that. So coming back a bit to the anytype. The anytype can be a little bit dangerous because it's just like any other variable in JavaScript. And what I mean by that is that let's take a look at, let's just look at this example. So here we can pass anything we want into this function and it'll operate exactly how we expect it to. All we're doing is console.log the value. And in JavaScript you can pass anything to console.log, so this isn't going to be a problem for any code. And right here's a few different examples, like an integer, null, hello world, and then a new date object, so it can support richer, more complex objects as well. But what if we specify a type? So now we've said, well, this function expects a date type, a date object. And you can see the compiler is angry at us, but the output is the exact same. So the compiler is saying, you shouldn't be doing this, but if we compile it down, it runs and behaves how we'd expect it. But this can be a bit problematic if you're operating on anything explicit to that type. So if you operate on the any type, if you use the any type in your functions, but you're using something exclusive to a specific type like the date object, you're going to have a bad time. So here's a bit more dangerous of an example. So let's say we're using this val.getUTC full year in our value function. Because we know we're passing a date type, this is fine. The compiler's not going to yell at us. We don't have to do any type checking because that's what TypeScript compiler is doing for you. But if you still use the same function calls down here, if you pass an integer, null, or a string, the results are very different. So in the first and third example, it's just undefined. But in the second, you can see that it's actually going to halt the JavaScript execution, and that could be pretty critical. So TypeScript lets you define these types using type indentations as for parameters in your function. And this lets you forego type checking in your code. You don't need to say if this value is instantiated and blah, blah, blah. And that makes it a lot cleaner, a lot easier to maintain. So one thing I wanted to mention before I move on, I mentioned earlier the great IntelliSense you can get out of TypeScript. And in vanilla JavaScript, at least in Visual Studio Code, when you're using a date object, you get all of this anyways, so you don't need to be using TypeScript necessarily. But in Visual Studio Code, all of your user-defined types, interfaces, classes, whatever, all get the same level of methods and properties, and all of your comments are shown as documentation towards them. So the IntelliSense is really good. It's intelligent IntelliSense, and I can't recommend using VS Code enough if you're interested in using TypeScript. So I've mentioned interfaces a little bit before, and they're the first main construct in TypeScript. They're the easiest and the simplest one. So let's talk about what that means. Interfaces represent a contract that an object must fulfill. So what that means is if you have an object, it needs to be of a certain shape. It has to have certain properties to be considered that type. So here's an example. We have a person interface with a name string. Now, we've got this function that expects a person object. Below, we've defined an object that says name equals James. But then there's this extra property. So interfaces don't have to be explicitly fulfilled. They can be minimally fulfilled. And what that means is because we've minimally fulfilled that contract with the name property on this object, it's inferred that it's okay. It's the person type, and we can use it as such. So down here, when we say show name and just pass this object, it's not going to yell at us because it minimally fulfills that contract. So it lets you have any extra properties so long as you have the requirements defined in the interface. So interfaces can extend one or more other interfaces, of course, to make complex objects. So another example would be we have an animal, and it has a name, and then we have a dog. So a dog is a type of animal. Again, this comes back to object-oriented programming. Dogs have a breed, but anything that is a dog will have a breed and a name because it'll be inherited. So down here, we're doing something like what we did before. Instead of defining name and having extra stuff, though, we're doing something a little bit different. So you can see that let my dog equals less than dog greater than. So what that is doing is called a type assertion. It's a lot like casting in other languages. And we're saying this object is going to be a dog, and we're telling the compiler this can only be a dog object. And that means that it has to have exactly the properties defined in the dog interface. So before I mentioned that the contract can be minimally fulfilled by an anonymous object, but now it needs to be explicitly fulfilled by a non-anonymous object. Because we're using this type assertion to say this is a dog object, we need to have both breed and name, nothing more or less. One interesting part of interfaces in TypeScript is how they compile down into vanilla JavaScript. No problem. So, like I mentioned before, with the type annotation in that function, it just disappears when you compile it because that's a developer feature for you. Similarly, this is the compiled code. So this interface and the entire thing you've set up in your TypeScript just kind of disappears. And that's pretty good because then you can use interfaces and the inheritance that they provide to create kind of richer objects and related data models and things like that without actually bloating your source code.
Got a quick question before you move on. The type assertion, when you put dog there.
I've never used TypeScript with React, but I imagine if that syntax is a problem in React, then you could just use the as keyword, like you mentioned.
Okay.
So
I wasn't sure if that was deprecated.
I don't think it's deprecated, but I think if you're using any React data models, I'm sure I'll have to look into that for you, because I'm sure there's a way to use React and this syntax together. Maybe something changes when you're using the React libraries or packages in your code. I'm not sure. So the other major construct in TypeScript is classes. And classes and interfaces are extremely similar. You can kind of use one where you want to use the other. And that's because of JavaScript allowing you to use anonymous objects and variables. So you don't need to instantiate new variables all that often. But you can and should whenever you need to maintain state in your application. Sorry. So classes and interfaces, the big difference is that interfaces provide definitions. So let's say you create an interface for a certain service provider in your code, and it has certain properties and functions. All of the functions won't have code in them, right? They'll just say a function that a function called print or something similar should exist in any object that is of this type. But I'm not going to tell you what the code inside that function is because I'm just an interface. I only tell you that there should be a function. In a class, you provide the implementation details. It's a concrete implementation of an interface in a lot of object-oriented languages. So if you had a similar function, like print or something, then you would have to say print and provide all the code as an implementation and say this is how print works, not just say there is a print function. So again, like I said, there's a lot of places where you can use either interface or a class. So here's an example of where I've switched interface with class. And this operates the exact same. This is functionally the same code. But what I mentioned before is that interface completely disappears from your compiled code base. Meanwhile, classes do not. This is the compiled code for classes. As you can see, there's a lot more going on, and that's because classes are already kind of a pseudo-construct in JavaScript. So it tries to say, hey, we can do classes, we can have state in these objects and stuff. But because of this, I recommend always using interfaces unless you need to use classes. I always default to using interfaces. So let's just reiterate, what's the difference? Interfaces provide type information to the compiler in the form of a contract. So the shape of an object needs to be minimally or explicitly fulfilling that contract that you define in the interface. And the difference between minimal versus explicit, that is dependent on the context in which you're using the object. So you can use type assertion to just say, be a dog, or you can kind of have the compiler infer that information. Classes are something that you're going to be instantiating, so there'll be something where you say var dog equals new dog, and you would pass some values, a constructor would be created, and then you have access to a stateful object, and this is great for any kind of data-driven application. So if you've got a web app and you've got a bunch of user models and stuff in your database, you can access a user from your database and wrap it in your intelligent class, manipulate it in some way, and then save it back to your database. So it just helps you manage state of your data, basically. So let's look at how they behave together. As you can see, interfaces can extend one or more interfaces. So that means that all of the properties in one will be inherited implicitly into the other. Classes can also extend interfaces, and again, that's an implicit inheritance of all of the properties and methods from the interface or class. So the implements portion right here is where things get a little bit weird. So classes, of course, can implement an interface. That's just a very traditional, normal, object-oriented principle. When you have this definition, then your class can provide a concrete implementation of an interface. But classes in TypeScript can actually also implement other classes, which means all of the properties and methods inside one class need to be explicitly defined inside your other class. So if you've got a function for print something, and then this one has a function for print something else, if a third one implements these first two classes, it has to have the print something and print something else functions explicitly defined, and then whatever else is in this class. So that feels a bit wacky to me. I know in C# you can implement other classes, and that's the same. You have to explicitly define the properties and functions from one class into the one that it's implementing. But the simpler kind of understanding of this is classes implementing interfaces because they provide concrete implementations that you're going to be using in your code. So let's take a look at how we can get started. So I've got this app, this demo that I've written. You can check it out. The full code is available on my GitHub here. But I'm going to walk you through, it's just a basic Node web app, and we're going to go over the different features of TypeScript actually written out. So again, like I showed you before, this is kind of the first step to creating your TypeScript application. So you create a project directory, you go into it, you start with npm init because this will create your package.json for your Node web app. And then you can do tsc -init because that's going to create your tsconfig.json. So that's the heart of every TypeScript project. It defines the compiler rules and anything else that needs to be known. Next, we need to install Express and any other packages that we're going to be using in our TypeScript and JavaScript. So one thing to note is this @types notation. @types is just an organization on NPM that has type definition files available for a lot of popular npm packages to make them available in TypeScript. So you see things like @types node. That lets us use things like path and file system in TypeScript. And when we compiled it down, it's also available to our regular vanilla JavaScript. Same goes with like body parser and express. But just right now, there is a versioning issue, the last time I checked at least. So if you install Express, just using the @types express, it'll be visible and available to your regular, or to your TypeScript. But when you compile it down, your JavaScript can't find it. And that's just like a temporary versioning thing. So for the sake of this example, I did npm install express pug and saved it so that my vanilla JavaScript could find it. But then I also installed the type definitions so my TypeScript could find it. So let's break out of this. OK. So here's a really simple app. I just want to say one thing about this. I've written my app.js file using TypeScript, but there's actually not any particular benefit to doing this file in TypeScript. The TypeScript benefits come out when you're building data models and any other backend software. For your app.js file, your server file, it doesn't really matter. I just kind of did it for the sake of example. So we've got our imports where we need our path and express and our body parser. We set up our middleware, define our routes. Here again comes this type annotations. So we're just using the any type here. But there's something I did want to talk about a little bit, which is linting. So are we all familiar with the concept of linting? OK, so linting is kind of just finding undesirable code. That's not necessarily a problem, but it just kind of cleans up your code, basically. It finds code that could be less maintainable, less problematic in the future, but it's not code that won't compile or anything like that. So here's just one simple example. It just kind of helps you maintain standards throughout your applications. Here we can see this is a compiler error because this has no type definition, right? And in my tsconfig.json right here, I can say no implicit any if I want, right here. And what this would let me do is say, I want to be able to implicitly use the any type, so let the compiler figure out that I mean the any type when I don't do this. So there's no type annotation. Right now it's not yelling at me because I changed that rule. But the default, the default is true. So everything needs a type annotation. Everything needs to be explicit. And now it should yell at me again. Oh. OK. Whoops. So there we go. And now you can see, oh, it's not yelling at me. Well, I would expect it to. And when you compile it, maybe it would find that. Right now, it wasn't. But linting is a bit different. So here you can see instead of ts in the left-hand side of that error, it's saying tslint. And that's an extension I've got installed in VS Code. So this is saying we shouldn't use the function keywords, so non-arrow functions are forbidden. And that can just help you maintain better code. It's kind of just a coding standard. So it's kind of like linting is like finding lint on your clothes. It's not a big problem, but it's kind of undesirable. It kind of makes things a bit of a mess. So to fix this, we could just turn this into an arrow function. And now we've got code that follows a certain standard, and that just helps you write cleaner, maintainable code. So let's take a look at what we've got here. I've shown you the tsconfig.json, and these are all your compiler rules. When you do tsc-init, this is what's provided for you. So all of the ones that are commented out by default, but this is just to let you know all of the different options available to you so you don't have to run back and forth searching through docs online and stuff. And I think that's pretty neat. It's a nice little feature. This is your package.json, very basic. So these are just your compiler options. This is your package.json, very normal for a Node app. Your launch.json is a configuration that gets created for you when you debug your application, and I'm going to talk about debugging and mapping files in just a sec. And then you've got your tslint. So by default, this rules block is empty, and there's a bunch of rules that are turned on, and some are turned off, but you can come in here and create anything you want. So for example, if I show you some data models that I've created for animals and stuff, here, this whole block is red, and that's because tslint only wants you to create one class per file. So I don't really like that rule, max classes per file. I can just ignore it right here, and now it's happy. So this code, again, is totally fine and will function, but it's just to maintain cleaner coding, and your code base will be thankful that you use a linter. One other compiler feature I wanted to talk about, source mapping. So this is off by default, but I think you should turn it on because this creates a mapping file that tells a debugger, and it has to be certain IDs, I imagine, but it tells the debugger where in your JavaScript code came from in your TypeScript code. So you can debug in your TypeScript code even though you can't actually run TypeScript code. So the mapping, so here, like if I have app.set all these different values and import all these different libraries in my JS file, it's a bit different. So we've got all these require statements, and these lines are the same, but a lot could be very different. Because of that, we can use this mapping file, and the mapping file is not very user-friendly, it's just a bunch of codes. But this can tell a debugger where certain JavaScript came from. So now we have the option of, say something in one of our routes isn't working properly, we can add a breakpoint, and when the JavaScript is executing, it can use that map file to find where that is in your TypeScript. So it gives you source code debugging, which is pretty great. So let's just take a look at our application, something really simple. Here we go. Again, we can see that we've got our route here that says just go to index whenever root is requested, and then if the form gets submitted, we can change the color of the box that our form is in. So here we've just got the default, we can do blue or green. This is kind of nothing really interesting, right? This is just showing you the way you can set up a route and pass data into your TypeScript application, right? Into your view. But let's do something a little bit more interesting. So the big benefits of TypeScript are interfaces and classes, and these let you wrap your data into intelligent objects. So let's say that you wanted to have a database model built into your TypeScript. You can create a bunch of models, and like I've done here, we're going to be just using cats and dogs again. So we can import our cats and dogs and just uncomment this bit of code right here. So now we're saying when we submit this form, we're going to actually be creating a new instance of this dog class. Well, let's take a look at what that actually is. So here, now we're using some of the features of TypeScript. We have an interface, and then we have our classes. Notice that I'm not exporting the interface because there's no need to make that publicly available. It can be private, it can be public, it's going to disappear in your compiled code regardless. But our class is the one we're interested in, so we do export that. Here we're saying every animal has to have an ID, an age, a name, a URL, as well as a function, speak, that returns a string. It doesn't matter what's in the function, how it operates, or what it does. Let the class decide that. The interface is just saying it needs to have one. So now we've got our class, dog, and it implements animal, we have all of these different properties in our object. And when we run our constructor, they get instantiated with the given values. Now here we have our speak function that was defined up here in our interface. And down below, we're saying, okay, here is how the speak function actually operates. It's a concrete implementation. So we're doing the exact same thing down here. We have an ID, an age, a name, and a URL. Again, right here, I'm assigning it a value, but if you were pulling this from a database and you created something new, you would just pass it values you've pulled from the database, manipulate it in some way, and then be able to save it from the database. So let's look at using this. Instead of just running node app.js, let's say we're interested in looking at this dog object. In a real production environment, you would probably pull something from the database and you're curious to see what your data looks like. Maybe there's a problem and you need to investigate. Now we can come into the debugger. So I already have this launch.json file created, but this gets created for you in VS Code, so you don't need to worry about it. The very first time you debug, it'll ask you what kind of environment or configuration you're trying to work with. So let's come back to our code. We can run the debugger, and there we go. When this route gets hit, we're going to be able to, did it not cancel out? Let's retry. Says the port is in use. Let's just close that. Stop. Redo. Okay. There we go. Listening on port 443. All right. So let's reopen that. Again, you can see we've just got our boxes. They're not very interesting. You're just kind of submitting data through. But now we can look at our models. So we have here the same form, and now we're just kind of requesting for a cat or a dog. But this is how you would set up a way to bring data in from your database and present it in a view. Right now, of course, I'm just creating static objects for the sake of example. But if you had a database connection, you would pull that information, manipulate it in some way maybe, and then present it to the user in your view. So here, if the form submitted dog, we create a new dog, and then this runs that constructor that I showed you. So it instantiates all of those values. And then we can render and pass the dog's information to the user. Same thing goes with cat. We can pass that information once we've instantiated this object. So it can exist throughout multiple requests, and you can manipulate it in a bunch of different ways and then save it back to your database. So let's see what that looks like. Here, we request a dog. Oh look, now we've hit our breakpoint, and this is in the TypeScript. So our debugger is using that mapping file, even though we're running JavaScript, to say, hey, this point that they've requested to stop at in the TypeScript file is somewhere here in the JavaScript. So now we can say we have this dog. We can look into what it has, and in this case, obviously, it's pretty obvious because I provided all the values right here. I just hard-coded them. But if you got it from a database, this would be a lot more useful because now you can stop and look into what your object actually has. So now we can just press play because we've looked at it, we're happy with what it has, and we've got our view. So you can see that we've taken data from our data model, we've brought it to the view. And we can do the same thing with cat. And again, it's a different data object that we've created. And we've only instantiated it in this small request scope, but again, it can live longer than that and can be manipulated across a few different web requests, and you can store it in a session, for example, things like that. So that's the basics of doing the development. And the debugger is it's an important tool if you're not familiar with using debuggers and you kind of just always do like console statements. It's a huge quality of life improvement when you upgrade and start using debuggers. So I still know people who work professionally as developers and they just use console.log everything, and don't do that. So that's about it. And if you want any more information, you can go to either of these two websites here. So docs.microsoft.com is the hub for anything Microsoft related. It's got all of our excellent documentation. It's all open source too, so if you see a problem with the documentation, you can contribute. And then there's TypeScriptLang.org, which also is very well documented. Anything at all that you need to know about TypeScript is available there. So thank you.
Hey, I'm VJ. Thanks for coming to the meetup today. I'm the organizer for JavaScriptLA. I wanted to just personally thank you for watching this video. If you found it useful, I'd love for you to subscribe to our channel. We're slowly but surely making lots of little video content for you guys to enjoy and soak up, especially if you want to get better at programming. I'd love for you to be on our Slack channel too. Over 800 users. The link is right here, jsjoin, jsjo.in. If you forget, it's really simple. If you have questions for this meetup, or questions you didn't get to ask, or because you couldn't make it, we'd love to have you just post it in our Slack group. So if you're a newbie, don't worry. It's a good place to go. There's a lot of great engineers all connected around LA and Orange County, so I hope to see you there.